Welcome everyone. For today's prep, we're going to see how to calculate the equation of a tangent line. So we're going to kind of put all the pieces together that we've been looking at so far. So very first thing we did is we saw how to find just the equation for a general line. The next thing we did is we saw how to estimate the slope of a curve by kind of sketching the tangent line. And then in TL3, we saw how to use the derivative, and in particular the power rule, to help us get the slope formula for our curve. So we're essentially going to be putting together all three of these things now so that we can write down the exact equation for our tangent line. All right, so we're going to start with our point slope formula. And if we remember, there's really three ingredients that we need in order to use this point slope formula. And remember, the point slope formula works for any line, not just tangent lines. So there's really three things we need for this formula. We need the x coordinate that we're looking at. We need the y coordinate of the point that we're looking at. And then we need the slope of our line. So there's those three things we need. Well, now when we use this to get our tangent line, let's kind of look at the pieces there. So we're still going to need those same three things. We're going to need our x coordinate, we're going to need our y coordinate, and we're going to need our slope. Now, the x coordinate, that kind of stays the same. So usually we're given the x coordinate or we're given information about the x coordinate. Now, sometimes we might not be given the y coordinate. Sometimes we will, but sometimes we won't. So how do we find the y coordinate when we're talking about a tangent line? Well, this is where we use the original function. So we take our x coordinate and we're going to plug that into our original function. So for our y coordinate, we're using our original function. Now, how do we get the slope? Well, the slope, this is where we use our derivative. So the slope of our tangent line is going to be the derivative evaluated at our x coordinate. So we're using our derivative, our slope formula. Remember, our derivative is our slope formula. So f prime, this is the special function we call the derivative of f, but this is really the slope formula that tells us the slope of our curve at any point that we're interested in. All right, so we're going to use our point slope formula with kind of these three ingredients, and that's going to give us our tangent line. So let's try an example. All right, so let's find the example, or find the equation of our tangent line, and the function we're looking at is the cube root of x, and we're looking at the point 8, 2. All right, so let's start by writing down the three things that we need. We need our x coordinate, we need our y coordinate, and we need our slope. All right, so let's look. What information do we have? Well, we have a point. So this is telling us the x coordinate and the y coordinate. So let's write those down. So the x coordinate is the first number, so 8, and then the y coordinate is the second number. So if we weren't given the y coordinate here, we could still find it by taking 8 and plugging it into our original function. So the cube root of 8 is 2. All right, so we're going to need our slope. So that means we got to calculate our derivative. So let's calculate our derivative. So our function is the cube root of x. A way to think of this, as we've kind of dealt with these root functions before, a way to rewrite this is to rewrite it using a fractional exponent. So we're kind of thinking this function, we could rewrite it as x raised to the 1/3. So remember, this little number here that's telling us the root becomes the denominator in that little exponent fraction. So the cube root, the third root of x, is the same thing as x raised to the 1 over 3 power. So if we have our root function here rewritten, now we can use our power rule. So the derivative, we bring down the exponent, so 1/3, put it in front. We keep x the same, and then we subtract 1 from the exponent. So our exponent was 1/3, and we take away 1, we're going to end up with -2 over 3. All right. So we have two formulas here. We have our original function. This tells us our y-coordinates. And now we have our slope formula. We have our derivative. So in order to get the slope of our tangent line, we're going to use our derivative here. So we're going to plug 8 into that derivative formula. And when we do, well, let's plug it in. So we're going to get 1 over 3 times 8 raised to the -2 over 3. All right. So we can leave it just like this. But if we wanted to, this actually does simplify. So the cube root of 8 is 2, and this actually does, this 8 raised to the -2 over 3 simplifies to 1 over 4. And if we multiply, we get 1 over 12. So if you wanted to, you could simplify it. Perfectly fine, though. Just leave it like that. All right. So we've got all 3 ingredients now. So now, once we have all 3 of those things, it's kind of the first part of this. We got to find the 3 ingredients. Get those 3 things. Those are the 3 things we need for a tangent line. And then once we have those, now we go to our point slope formula. Kind of like problems we've done before. All right, so we have y minus our y-coordinate is equal to m times x minus the x-coordinate. And again, the x-coordinate we have, so we'll be able to fill that in. Our y-coordinate we found, so we'll be able to fill that in. And our slope, we actually calculated. So you could use either one. You could use kind of the unsimplified version here, or we'll use the simplified version though. And so we just fill in the pieces then. So our y-coordinate is 2, so we get y minus 2. Our slope is 1 over 12. And then our x-coordinate is 8, so we get x minus 8. And directions really didn't specify any particular format, so this is good. So we got it. And that's the idea. But again, if you didn't necessarily have to simplify this, so you could have equally as just, well, have put in that 1/3 times 8 to the -2/3. So the one thing to remember when we find the equation of the tangent line, even though we're calculating the derivative and the derivative has x's in it, this is the slope formula. So when we're trying to find the slope, we want the slope at this particular point. So the slope ultimately should be a number. There shouldn't be any x's here. So we're going to be finding the slope formula, but then we have to evaluate it so that we get the slope at our particular point. All right, so we'll try another example like this in class. So we'll see you then. Bye-bye.